to lesson number 5, which is going to be factoring methods. It's actually just one method that we're going to talk about today, which is the Berry method. So the Berry method is pretty easy to use. It's meant for situations when we have an A term that's not equal to 1. Okay, this is when we're going to use the Berry method. As you can see, the examples we have here, right? We have an A term that's not equal to 1. Okay, so here are the steps to the Berry method. First, we're going to multiply our A and C terms, and the product that we get, we're going to call it C prime. And we're going to rewrite that expression without the A term, and we're going to replace C with C prime. Second step is we're going to factor. We have all different ways we can factor, right? Hopefully we'll be able to do this just by looking at it. If not, we can use completing the square or even the quadratic formula if we need to. Step 3, we're going to divide each factor by the A term and reduce if it can reduce. If it can't reduce, we're going to move right to step 4, which would be move the denominator value to in front of each corresponding x. Now these last two steps are a little bit trickier than what you would normally think of because this is a new process. So they'll make more sense once we actually do an example out. So with our steps still showing, we're going to do this problem. It tells us that for our very first step, we need to multiply the A and the C term together. So I end up getting 15, and we're going to rewrite now without the A term here, so it's going to be x squared plus 8x, and now I'm going to add on my C prime value. Now I should be able to factor this thing. So I got to think about what two numbers multiply to 15 to add to 8. I'm coming up with 3 and 5. Okay, step 3, this is where it's a little bit different, right? Now we're going to divide each of the factors by A and then reduce. So my term here, my A term is 5, and I'm going to be dividing these numbers here. So this is what it looks like. Okay, so I divided each by 5, and now I'm going to reduce. Here I can reduce, right? My 5's reduced, that becomes a 1. Here, this doesn't reduce. So what I'm going to do instead is I'm going to move to step 4, which says move the denominator so it's in front of the x. So my denominator here is 5. I'm going to move that in front of the x. 5x, and now I'm left with plus 3, and now I have factored using the Berry method. Okay, we'll try that again with the next problem. I'm going to take my A term, multiply it by my C term. That's going to give me negative 24. I'm going to rewrite without the A term now, so x squared minus 10x, and I'm going to add this now in, so minus 24. This should be factorable. In fact, what I get is negative 12 and 2. That's going to multiply to 24 and add to negative 10. So x minus 12 and x plus 2. My next step is to divide by my A term, which here is 3. So we have x minus 12 over 3 and x plus 2 over 3. Reduce what we can. So this 12 over 3 is going to reduce to 4. X minus 4. Here this doesn't reduce, so my 3 is going to go right in front. And that's our factored form. There are 2 here at the bottom for you to try. Pause the video and press resume when you're ready to check. Alright, let's check out how you did. Here's our A and C terms. When we multiply those, we get 12. We're going to rewrite without the A term and using our C prime term. When we factor, let's see, what are we getting for factors? I'm getting x minus 2 and x minus 6, right? The double negatives gives us plus 12, and then negative 2 and negative 6 is negative 8. So that worked out well. Then I'm going to divide by my a term. This does not reduce any, so I'm going to move that 3 to in front of the x. Here this does reduce. We get 2. It's okay if these are in switched order. That's fine. The second one that you had, we have 2 times negative 9, which is negative 18. We're going to rewrite. So we have x squared plus 3x minus 18. Alright, well let's see. If we want to break this up into x plus 6 and x minus 3, right? The positive and negative gives us negative 18. Positive 6 minus 3 is positive 3. So that worked. We're going to use 2 to divide. And reduce. That's going to give us x plus 3 here. This 2 is going to come in front, giving us 2x minus 3 for our second factor. How'd you do with those two on your own? Hopefully you did okay with them. What we're going to look at next is just some terminology, really. It's going to be the same process, but you're going to see instructions now. They're going to say things like find solutions or roots or zeros. Don't worry about that. It's all the same instructions. So if they say to solve or roots or zeros, it's just solving. Okay, what's going to look a little bit different is we'll either have this written as a function, or as you see here, we have it equal to 0. Either way, if I'm trying to find roots or solutions, I'm trying to figure out what values I can plug in to make it equal to zeros, which is also why they call it zeros. So what we're going to do is factor, and we're going to use the Berry method to factor, but in the end, we're going to set each of the factors equal to 0 and solve, and that will give us our roots or zeros, solutions, whatever you want to call them. Okay. So here's what we're going to do. We have 2 times 2, which gives us 4. Rewrite using that 4. We're going to factor. Let's see, I'm coming up with 4 and 1 as my factors. We're going to continue using the Berry method. We've got to divide by 2. And then reduce, right? This 4 divided by 2 is going to reduce to x plus 2. This does not reduce, so I bring my 2 up front, giving me 2x plus 1. Now this whole time, we've had this thing equal to 0. Okay, it's been here this whole time. What we're going to do now to find the roots is set each of these individual pieces equal to 0 and solve. Here I would subtract 2x, and I get negative 2 for one of my solutions. The other one, subtract 1, divide by 2, and we get our second solution of negative 1/2. So here's our zeros or roots, negative 1/2 and negative 2. So up to this point, it's what we were just doing before, Berry method factoring, and from here, set them each equal to 0 and solve. Okay, another problem, basically the same instructions, right? Find the zeros. Same thing. So let's do our Berry method. 4 times 3 gives us 12. Rewrite. Alright, let's see. What numbers can I use to make 12? How about 4 and 3? Those are going to add to give me 7. So that worked. I'm now going to divide each term by my a, which is 4. and reduce where I can. Get x plus 1 for my first term. I can't reduce here. We end up with 4x plus 3. This whole time we've had this equal to 0. Now comes the solving part, finding the zeros. Right? X plus 1 equals 0. Subtract 1. I'm coming up with negative 1 for one of them. 4x plus 3 equals 0. And we get negative 3 over 4 for our second solution. So when we write them down, negative 1, negative 3 over 4. Okay, so I've got one for you to try on your own. Try it out, see how you do. Resume the video when you're ready to check your solution. Okay, let's check it out. Using the Berry method, we have 2 times 5, which gives us 10. Rewriting it, x squared plus 11x plus 10. I'm looking at that 10 and that 11. I'm thinking we're going to have to factor this as x plus 1 and x plus 10. It's the only thing that works here. Next step, we're going to divide by our a term, which is 2, and reduce. 10 and 2 reduces, so we get x plus 5. This does not reduce, so my 2 goes forward. And these are the two terms that we get when we factor. Remember, this was always equal to 0. So now when I want to solve, which is finding the roots or zeros, I just set each piece equal to 0 and solve. We got negative 1/2 for the first one. Negative 5 for the second one. So we'd want to write it this way. Negative 1/2 and negative 5. I'm hoping that you got those same solutions. We got one more thing we're going to look at. Okay, and it's putting it all together. Now we've used some of the materials from this lesson, and we're going to be using some of the materials from previous lessons, including sketching. I want us to get better and better at sketching. Okay, so here's what we're going to do. We're going to sketch this graph. We're also going to identify the vertex, axis of symmetry, y-intercept, the roots, which is new, and the min-max value. And here's the function that they give us. F of x equals 2x squared minus 13x plus 20. Right away, I identify this right here. It's our y-intercept. So we can actually answer one of these things right now. Y-intercept, we know we're going to be at 0, 20. Okay, so that was a quick one. Next, let's look at the axis of symmetry. We remember, hopefully, that the formula is negative b value, which is negative 13, divided by 2 times the a value, so 2 times 2. Let's see, negative and negative, that's going to give us positive 13 divided by 4. Now we could leave it as a fraction. I usually do. However, in this situation, I think it's going to be easier to work with a decimal. So we're going to get x equals 3.25. Now, the reason why I'm working with a decimal is because I'm going to be plugging this into the formula to get the rest of the vertex. And seeing as it's a fraction, it's probably a lot more difficult to type into my calculator. So I'm going to use this decimal. Okay, if you want to use the fraction instead, go for it. And I can even show you how to type those in to calculator at school if you need to. So, finding the vertex, we need to evaluate the function at 3.25. So we're doing 2 times 3.25 squared minus 13 times 3.25 plus 20. If you type this all into your calculator, you could use Google's calculator if you want. You can use a school calculator, which is a TI-84, or if you have your phone, you can download a graphing calculator program. I suggest Desmos. That's what I'm going to be using. DESMOS, really good program. Okay, so I'm going to type this directly into my calculator, and it's going to perform for me. And assuming I type everything in correctly, I'm going to get negative 1.125. Okay, and I will double check to make sure that I typed it in correctly. Okay, so for my vertex, we know our x coordinate is 3.25. We got our y coordinate to be negative 1.125. So we got the vertex, axis of symmetry, y-intercept. Okay, min or max value. Well, I see that right here we have positive a term, which means that we're going to have a minimum, and it's whatever our y happens to be. So we have a minimum of negative 1.125. Now we've got to find the roots. Okay, in order to find the roots, we're going to have to do the Berry method. So we're going to do 2 times 20, which gives us 40. We're going to rewrite. Ooh, that's a tough one, 40. Well, I'm thinking about 8 and 5, because 8 and 5 is going to give me 13. They should both be negative, because that'll end up giving me the negative, and double negatives gives me the positive 40 that I need. Going to divide each by our 2. Divide by 2. That reduces to x minus 4. This does not reduce, so we move to the front. I'm going to set each of those equal to 0. Solve by adding 4. So I'm going to get 4 for one of my roots. The other one, I have to add 5. And divide by 2. And we get 5 over 2. So our roots, we came up with 4. Let's see, 5 over 2, that's 2.5. So we found everything that they looked for. They also want us to sketch. So we're going to sketch this graph real quick. Okay. Here's my y-axis. Now thinking about it, my vertex, the lowest point, is negative 1.125. And I have a y-intercept of positive 20. So that means that most of my graph is going to be up here in the positives. I only need a little bit in the negatives. Okay, so let's see. We'll call this, let's see, we'll call this one 20. And if this just about right here is that negative 1.125, just about. Okay, so we've got our y-intercept, our axis of symmetry is coming down right here at 3.25, which means that our vertex is right here. The only other point that I really need to worry about are our roots, which we have one at 2.5, which is just about right here, and one at 4, which is just about right here. And then I have one more point. It's going to be equally distant away. So that was 3.25. If I double that, that's up here at 6.5. So let's see. 0, 20, 6.5, 20. This is our vertex at 3.25, negative 1.125. We'll just draw these lines up. This is 0, 4, and this one is 0, 2.5. And there you go. There's your sketched parabola. So there's one more for you to try on your own. Pause this video and resume it when you're ready to check your solutions. Alright, let's check this one out. We're going to sketch after we identify all this stuff we need to. I'm going to look for the y-intercept right away. So we get a y-intercept of negative 2. Then we're going to find our axis of symmetry. Our b value here is 9. Our a value is 5. So we end up getting negative 0.9 for our axis of symmetry. If we plug that in for our vertex, we're evaluating at negative 0.9. So we have 5 times negative 0.9 squared plus 9 times negative 0.9 minus 2. We're going to type that into a calculator very carefully. And what we end up getting out is negative 6.05. Again, make sure that you type that in carefully in your calculator. So here's our vertex. Negative 0.9, negative 6.05. As far as min-max, this is positive. That means we have a minimum. And our minimum is going to be our y value of negative 6.05. Now we got to talk about the roots. Last time we're going to have to use the Berry method. We're going to do 5 and negative 2, which gives us negative 10. So we rewrite let's see, that negative 10, I'm going to have to do x plus 10 and x minus 1. That's going to give me the negative 10. Positive 10 and negative 1 gives me the positive 9 that we needed. We're going to divide by our a term, which is 5. So let's see. We got x plus 2 and 5x minus 1. But then we have to set each of those equal to 0. So x plus 2 equals 0. Subtract 2. We get negative 2 for one of our roots. 5x minus 1 equals 0. Let's add 1. Then divide by 5. So we get 1/5 for our second root. So here they are, negative 2 and 1/5. Last thing that we need to do now is just sketch this. The last time I sketched this, it came out looking pretty bad. So I'm going to take my time with it this time. Okay. What I'm noticing is my vertex, I have negative 6 is my lowest point. And my y-intercept is at negative 2. So most of this graph is below the x-axis. I have a little bit that's going to be hitting the x-axis. And it's mostly on the negative side, not quite to the positives. So here's what I'm going to do for my sketch. I'm going to make each of these worth 2. Okay, so here's negative 6. So negative 6.5 just, or 0.5 is just below it. Okay, and that would mean that, let's see, just about here is that negative 0.9, which is my axis of symmetry. Okay, so my vertex, which is right on that axis, is right here. I'm going to label that point negative 0.9, negative 6.05. Then they give us a y-intercept of negative 2. So I had said that each of these are roughly 2. So right here, that would be our negative 2. I should have something pretty much equally distant, right? I want it to be at just about 2, right? Because if I double that distance, that's negative 1.8. And we're going to be hitting at the same height. So we've got negative 1.8, negative 2 for that point right there. And last, we have a few more points. Our roots. So let's see. With our roots, we've got negative 2 is one of them. And positive 1/5, which is not very far. It's like right here. 1/5. Okay, so here are all the points, and we've just got to go right through them. All right. So checking each of the things that they're looking for, hopefully you found these items with no problem. Sketching the graph, a little bit more work than usual, but hopefully you did okay with that sketch as well. If you have any questions, please leave them in the comments or bring them into class, and we'll talk about them as soon as we can.